Small wind turbines, or SWTs, have struggled to get off the ground. Not only is siting more difficult for SWTs, but their low efficiencies rarely justify the high costs. They also have to contend with the same kinds of considerations that your typical turbine does, like noise, vibration, environmental impacts, and aesthetics. In closer proximity to people, these factors are that much more important and difficult to nail. So what are the options if we want to go against conventional wind turbine logic by thinking smaller, not bigger? Well, there's a lot of high-speed winds to make good use of, and they're not all in the mountains or out to sea. Those of you living in major cities probably know this, and someday soon wind turbines might be integrated seamlessly into your surroundings, assuming they aren't already. How can SWTs turn windy streets into an opportunity? When can apartment dwellers start to produce their own wind energy? And why was one SWT company inspired by a NASA rover shaped like a beach ball? I'm Matt Ferrell. Welcome to Undecided. This video is brought to you by Factor. We're at the point in solar's mass adoption where it's nearly ubiquitous in the clean energy transition. It's no secret that wind, even though it's more impactful in terms of bang for the buck, has been lagging behind. And part of the problem is that wind has a much larger footprint. You can slap a solar array right on the top of your existing roof, but you can't exactly stick a standard-sized turbine in your backyard, unless you downsize. However, as time has gone by and I've covered more and more of these types of SWTs on the channel, my opinion on residential wind, specifically in context of single-family detached homes like mine, has shifted with the breeze. I personally believe that in that case, wind is not appropriate for the vast majority of suburban homes. The land and location requirements are simply too much for the average homeowner. But that doesn't mean that residential wind in general has no chance. Truth is, most of the world lives in cities, especially in the US, where about 80% of the population resides in urban areas. Metropolitan environments pose unique challenges for harnessing wind energy though. O Innovations is one of the several companies rising to the challenge. Its turbine's design can, quite literally, empower apartment dwellers to produce their own energy with wind. I recently had the chance to interview Nicholas Oriana, founder and CEO of O Innovations and co-developer of the O-Wind turbine. As he told me,
if you live in a house in the rural areas, you can put on solar panels or whatever, and you make yourself responsible for it. But in urban spaces, there's no way. You're not responsible for it. You just give the problem to someone else. You just require a number of kilowatts hour per day. So first of all, raising awareness, making people understand that it is a problem that they need to be a part of. And secondly, giving the possibility to solve the problem, right? It's not just me feeling bad that I'm requesting something that I cannot provide. It's actually something I can take action on.
City planners and architects by design need to be conscious of the turbulence generated by and between buildings. The reason why wind turbines stretch so far up into the sky is that wind speeds are higher, well, where it's higher. It's no different in the concrete jungle. The problem is that without proper planning, these rowdy winds will rush down the smooth surfaces of tall structures, bringing them down to ground level. This is what's known as downwash. Also the reason why so many outdoor restaurant seating fails. Now that's far from the only physics phenomena at play. There's also the fact that wind accelerates when it collides with corners. Then there's the wake effect, yet another way that turbulent winds can travel to ground level and cause trouble, and the Venturi effect, which I'll get to in a minute. Altogether, it makes for a lot of chaotic, rough wind, and yes, a lot of lost hats.
In those places, you have really very accelerated winds, a lot of energy. We call this high energy potential spots. In these places, we can go up to 3 times the speed as in a normal open space, and that means 27 times the energy. But harnessing that wind, which goes in different directions, vertical, horizontal, diagonal, eddies, everything, and it changes speed as well. It changes and changes all the time. So it's really difficult to harness for any other wind turbines. Wind turbines are regularly designed for clean wind. That's what we call it. And that's why these big fans are located offshore or onshore, but in really specific places where they can harness that wind. Clean wind means a steady direction, steady speed. This wind in cities is totally the opposite.
But that hasn't kept engineers from looking for ways to tame those wild winds. And speaking of taming those wild winds, I think I need to tame my hunger. I'm filming this right before lunch and I am super hungry right now. So this is a good time to take a quick snack break with today's sponsor, Factor. Now my schedule is so hectic it's made it challenging to prepare nutritious meals at lunchtime. I was taking shortcuts and eating the easy, not so healthy stuff. Way too much. Factor really helped keep the stress out of planning and preparing what I eat while keeping it nice and healthy. And fun fact, I actually signed up for Factor well before they were ever a sponsor, almost 2 years ago. One of my favorite things is the variety. Factor offers 35 wholesome meals every week to choose from, like Gourmet Plus, Keto, Calorie Smart, or vegan and veggie options. It's really easy to find something you'll love, and I'm kind of obsessed with their peanut Buddha bowl. Factor isn't just flexible with what you eat each week, but you can pause or reschedule your deliveries anytime. No prep, no mess, never frozen, and it's ready in just 2 minutes. Head to factor75.com or click the link below and use code 50Undecided to get 50% off and free shipping on your first Factor box. That's code 50Undecided at factor75.com to get 50% off and free shipping on your first Factor box. Thanks to Factor and to all of you for supporting the channel. So back to all the engineers trying to tame those wild winds. Now, longtime viewers might remember how a while back we covered the Dutch company Ibis Power and its Power Nest turbine installation on the tops of flat-roofed buildings like apartment complexes. The Power Nest takes advantage of the Venturi effect, which is the tendency for wind velocity to increase as it funnels through a narrower channel. Now, the Venturi effect explains how forceful winds can bear down on pedestrians walking between two buildings. And I have vivid memories of walking to work in downtown Boston and feeling like I was in a wind tunnel experiment. Now, the O-Wind is built to handle all these nasty gusts, and it's what it does best.
This is not the turbine that's meant to take out all the other turbines in the world. It's not going toe-to-toe with offshore turbines. It's meant for a specific use case, which is the turbulent wind in cities and structures.
We've covered the Aeromine rooftop turbine a few times on the channel already, and while it and the O-Wind fill different niches, they do share a foundation. Like the Aeromine, the O-Wind's design relies on Bernoulli's principle, which is the basis for both how airplane wings achieve lift and how wind turbine blades spin. Now, that said, the O-Wind sets itself apart from other SWTs because of its ability to capture winds from any direction on both the vertical and horizontal planes.
It can take wind not only horizontal, but also vertical gusts and from below. So really omnidirectional. The word omnidirectional has been misused in the past by vertical axis wind turbines, but omni means all. So all winds includes vertical thrust as well.
So here's how it works. The sphere-shaped O-Wind is covered by a series of vents with larger openings on one side than the other. As wind moves through these vents, it creates a pressure difference. And according to Bernoulli's principle, as wind speeds up through the smaller exits, the pressure decreases. And this pressure difference creates the force needed to rotate the turbine. Oriana originally designed the O-Wind in college for a final project on space exploration. After catching wind of NASA's Tumbleweed rover, which was created for rolling around Mars, he was inspired to invent his own wind-powered device. He didn't adapt it for electrification until 12 years later.
I came across an opportunity to apply for a contest, and the scope was pretty wide, anything that solves a problem. So I thought, why not? Let's try and dust off this old invention and see if it can do something.
Now, the O-Wind in its current form can capture wind from any direction, but it only spins along a single axis. That means fewer moving parts that you need for steering. If you remember my video on the challenges of residential wind, you know that this is a big benefit. It's moving parts and the maintenance that they require that are typically small-scale wind's Achilles heel. So what about the other problems that have been hovering around wind energy? As of our August interview, O-Innovations had yet to get hard numbers on the turbine's noise levels, but according to Oriana, the O-Wind is virtually silent.
Whenever the wind is blowing, you can hear the wind. You cannot hear anything coming out from the turbine.
Pilot testing located at a farm has also shown that the O-Wind is relatively unobtrusive.
We have had so far in the pilot that I mentioned 1.5 years, and we haven't had any incidents with any kind of environmental issues or wildlife. No birds, no insects, no ants, no nests, no nothing inside. It's been great.
Now, these are all good things, but there's always the million-dollar question: is the turbine cost competitive? And the short answer: it depends. During our interview, Oriana emphasized that the O-Wind's performance is contingent on proper siting. Now, this is not an SWT for open spaces, and the first version that will be released to the market is a 2.2 meter or 7.2 foot diameter model, and it's intended for urban use. Oriana described the price point like this.
We think it's going to be comparable to the standard solar panel installation in the UK. Given the solar conditions in the UK, it's going to be pretty much there in the price tag and ROI as well.
As for the O-Wind's estimated power output, it ranges between 2,000 and 5,000 kilowatt hours per year. And that's enough to cover the average annual electricity consumption for households in the UK, but in the US, not so much. A single O-Wind would really only be relevant in certain regions of the States, considering that the average apartment tends to fall in the 6,000 kilowatt hour range. Now, note that these figures are based on 2015 data. Now, to put this in perspective, the average annual electricity consumption for all homes in the US in 2020 was about 10,566 kilowatt hours. It's worth pointing out here, though, that the US energy consumption is much higher than other countries. According to our World in Data, the average American consumes about the same amount of energy in 1 month as the average Indian consumes in an entire year. The average Brit consumes double that of the average Brazilian. So even though a single O-wind isn't meant for single-family homes in the States and probably couldn't enable New Yorkers to reach total energy independence, it's definitely not without its use cases. Now, currently, O-Innovations is working to publicly demonstrate the latest iteration of the O-wind, and the company has Spotify sponsoring its next pilot project. Once that round of testing is done, Oriana hopes to have the turbine on the market by the end of next year, which will be 2025.
There are turbines out there, and there are some people trying them. But altogether, it's not mature, right? There's still a lot of space for urban implementation, and there's not one yet that has made a breakthrough. So we hope we're going to be the first one to start populating the urban space with energy.
But what do you think? Will wind turbines become the new wind chimes, or should city slickers seek their renewables elsewhere? Jump in the comments and let me know. And be sure to listen to my follow-up podcast, Still to Be Determined, while keep this conversation going. Thanks as always to my patrons for your continued support. Keep your mind open, stay curious, and I'll see you in the next one.